we're coming over here. I have hydrochloric acid, a rather strong acid, and it is in rather concentrated form here, so certainly nothing to be messed with. But I have some hydrochloric acid in that test tube, and then I'm going to add some zinc. And when I add the zinc, the reaction will occur. I'm then going to put this stopper into the test tube, and you can see there is a hose on the end of the stopper. The hose is going to direct, through the hose, it's going to direct any gas that is made in this test tube into, over here, I have a tub of water, and I have another test tube. And by holding the test tube upside down under the water level like this, it's going to stay full of water until some gas comes out of the tube, in which case it would fill up this test tube. Now I point out earlier in the hydrogen peroxide decomposition, we trapped the gas in soap bubbles. This is a method we like for trapping a gas because it does not involve adding soap. I would have a pure gas. Whatever gas is coming through the hose would be pure inside this test tube. So that's the setup. I'm going to now drop in the zinc. You can clearly see that a reaction is occurring in the first test tube. Now this is over here. This is reaction 6. In that test tube, that's reaction 6. That is zinc and hydrochloric acid. I am not yet to reaction 7, but you can clearly see one of the results of reaction 6 is a formation of a gas. I am clearly getting a gas filling my test tube in this bucket here that I'm holding upside down. So that's a big clue as to how to predict the products. One of them has to be a gas in order to be doing this. Now that this test tube is full of that gas, I'm going to test to see what gas it is. So there's my test tube from the tub full of some unknown gas, and I'm going to test it. This time I'm going to test it with a flaming splint test. So I want my wood splint on fire still. And I point out, if this gas is oxygen, what would happen is the splint would burn better. If that gas is carbon dioxide, it would blow out the splint because fire needs oxygen to burn. If that gas is hydrogen, it's going to give me kind of a small, very, very, very small explosion sound and put out the splint because fire needs oxygen, not even hydrogen. So I would combust the hydrogen in there if there's hydrogen in there, but the splint itself, the burning, would go out. So this would help me determine, is it oxygen, is it carbon dioxide, or is it hydrogen, based on the combination of does the splint stay burning or does it go out, and do I hear a small explosion noise or not going on there. So I'm going to now get my splint burning. Yeah. Well, easier said than done apparently. There we go. Okay, so here's my burning splint. And here's my unknown gas, and I'm going to test it with the burning, well, rather annoying. Let's try this again. And I will move quicker once it's on fire. Okay, flaming splint test, here we go. Oh, we heard quite an explosion going on there. That was a good one. And it put the splint out. Notice it's no longer on fire. So that combination will tell me what kind of gas was in there. That is reaction 7. And I want to point this out for reaction 7. I had a particular gas in there that I burned. That means to do any sort of burning, that means oxygen from the air went inside and burned with it. I also want to point out, what do you notice inside that test tube now? Do you see those droplets of water? They weren't there before I burned it. So the combustion reaction must have also produced some product that would make these little droplets of water. Wink, wink, nudge, nudge. So there we are. That is reaction 7. Reaction 6 was the magnesium with the hydrochloric acid in the first big test tube, the bubbling one back here. That's reaction 6. And then down here, me combusting the gas in here, which was the product from that. So the product of that reaction is the reactant in this reaction with some oxygen, because I burned it. So oxygen came from the air and made some water, and that's reaction 7. So